All right. Hello, everybody, and good morning, good evening, good afternoon, and thank you for joining to Going Meta, episode 23, Advanced RAG Patterns with Knowledge Graphs. So this is a slight. I think it's the first, Jesus. We continue immediately
Well,
after previous episode with the
that
topic,
is
kinda.
that
Um,
it may be, yeah, that's probably right, but
yeah,
it's such a rich topic and
it
such an
is.
interesting one that I wouldn't be surprised if we spend a few more on it. But yeah, you're probably
Yeah.
right.
No, I'm sure we will, and it's a great topic. But first, thank you for joining, Jesus. How are you doing today?
I'm very well. I'm very well. I'm not as cold as you are probably, because
Yeah,
after seeing the pictures, it's pretty crazy over there, right?
it was crazy. Yeah, I was at my parents over the weekend, and basically from I mean it started snowing Thursday afternoon or something, and Friday evening it was already like 20-30 centimeters of snow. Saturday morning we woke up and it was like almost a meter of snow everywhere. We were completely snowed in. There was
That's
no way of getting anywhere. So until Saturday, Sunday early afternoon or something, we were kind of like left for
looks
us.
like the internet connections have not been affected, but I
No,
can
internet was good.
can see you well, which is great.
Yeah,
That's amazing. Yeah.
yeah. No, it's all good. It's now already seems to be thawing a little bit. So at least here in Munich, I'm back in Munich now. The temperature's gone up, but it was super cold. It was minus 15 or something. So
Wow,
yeah,
that's serious temperatures.
yeah.
I don't think we've
Yeah.
experienced that here in a few years. I mean, ever, I would say. But happy to keep things like that, to be honest.
Yeah, yeah, yeah. Don't need that every other day. So for sure. Now I know how our colleague Adriana feels like when she goes out of the house in Canada where she lives.
Looks like it's chilly in Chicago as well.
Oh yes, hi
Something
Daniel,
up there.
good to see you. Yeah, there's a little temperature drop here, and other places. So yeah. So it's good. But yeah, this is like I said, episode 23. Last episode we discussed a little bit of RAG and on all of that and how does it work? What does it mean? What is going on in terms of knowledge graphs and LLMs, and how does this also the two concepts flow together, or how do they combine well, and how do they
Mhm.
add things towards each other? I guess it's a good way of starting the conversation. If you missed it, don't worry. I think you can, as usual, even though this episode may be a little bit building upon what we talked about last month, but you're probably going to be up to speed quickly, and then you can always watch the episode
Yeah,
later
exactly.
on.
Yeah. Well, I'll do a couple of minutes recap of what we
Okay.
covered last session. But yes, the recordings are up and all the assets, so it's out there for everyone to try at home. And yes, it's yeah, should be hopefully. I mean, it's pretty dense. I mean, as usual, have loads of content. We'll see if we manage to squeeze it all in the session, but we'll see. If not, we'll have for the next session.
We have space for the next one, exactly. And yeah,
Okay.
if you watch us live, then please use chat as you go through the content. If you have any question, anything is unclear, any comments, even if you just want to say you like it, it's also nice to hear. But if you have any misunderstandings or anything is unclear, then please let us know. If you watch this after the fact that we stream this today, then obviously the YouTube comment section is a great place to put something in there. Even better yet, the community on Discord or on the Neo4j community forum are places where you can ask questions, and we can have a look for them there and help you out if anything is unclear afterwards.
Perfect. So shall I go ahead and share my screen?
Yep.
Let me know if you can see it. I'm going to be sharing my whole screen and moving these
Yeah.
out
There it
here.
is.
Oh, and I see Noel joining from Argentina. Probably he's having a completely different experience there. He's
Yes.
on shorts and a t-shirt, but also nice. Different type of Christmas to the one that we have here.
Yeah. Yeah,
Good, good. So you can see my screen, right?
I can see your screen. Yes, here we go.
Perfect. Good. So, well, yes, like you said, I'll take it where we left it last episode, right? And we talked about RAG, and just to recap and to refresh for those of you who missed it or who have been under a rock, like I said, because it's impossible not to have heard about a RAG. But RAG is kind of an architecture, right? It's like a framework, an approach. Is a way of building applications based on large language models, but integrating in real time with some external source of facts that's curated, that's trustable, that's explainable, and that enriches the whole. The quality and the traceability and explainability of the results. So that's high level what it is, and that can happen in many different ways. Of course, the one that we've been exploring here is when we use this kind of grounding partner, this external source being a knowledge graph. But the idea is like you see in these diagrams. So we have some form of front end. It can be an interactive one. We've looked at chat style applications, but it can be anything. And today, actually, we're going to be looking at something that's more kind of a batch process where we generate personalized content for emailing or things like that. So anyway, some form of application that interacts and leverages the conversation, well, not the conversation, the linguistic and the reasoning capabilities of an LLM, but that injects the knowledge of the world, the facts. Because as we've heard and we've discussed in the past, large language models are great at these things, at reasoning, at talking, at generating content, translating, summarizing, but sometimes they struggle with world facts. And of course, they've not been trained on your own private data, your organization's private data. So that's something that you're going to have to inject. And that's exactly what this architecture, this approach, that's RAG solves, right? So that's the idea. And again, last episode, we touched briefly on how RAG, knowledge graphs in RAG, improve the quality of the solutions. And I have the impression that, I kind of went over it high level, like saying there are types of solutions where the graph captures the structure of a document, right? So, and because you're structure aware, then you can leverage that structure to generate. And I'm going to explain what that means, because, that here we're big fans of not using just the words, but showing what we mean by them. But I talked about this kind of modeling in the graph, the structure of document, the sections, the subsections, the images, the tables, and things like that. We talked also about the idea of having a knowledge graph where we have entities, where we have relationships, and using that to enhance the result of a vector-based search by doing some semantic search, vector-based search, and then taking the results and doing some post-processing and contextualizing them, enriching them by navigating the graph. But even though I explained that, I have the impression that the demonstration, the experiment that we ran last time, look at the two approaches, the vector-based approach and the graph-based approach separately. And maybe some people came with the conclusion that you take one or the other, but not the two. And that's exactly what we're going to show today. So how the combination of the two in these two types of examples is really, really powerful. So the idea is that now, as you know, Neo4j supports vector-based search since the introduction back in August of the vector index. Now we can combine the two things, and that's really, really useful, and that's exactly the plan for today. So does that make sense, Alex?
Yep. Yeah.
Perfect.
I think that makes sense. Yeah, that's cool. That's interesting. I think that's a good point that we showed previously the two different approaches and that we now go and combining them. I think is an interesting
Good.
interesting story
Excellent.
today.
So yeah, so the first one focuses, and they're quite different from each other, right? The first one focuses on, like I said, on unstructured document, and it's something that we used a few weeks ago in the summit here in London, and it went out quite well, and people liked it. So I thought I'd reuse it here, at least a part of it. And here the idea is that we have a legal document. In this particular case, is something that my colleague Michael was asked to do by a customer. And there's this PDF, and you have the URL down there. It's some financial regulation in Ireland. And the document, it's a PDF. If you go to that URL, you'll see that it's described. It contains a number of parts. Each part contains sections. Yeah, it's natural language. And then sections contain things like definitions. I intentionally put that fragment. I don't know how readable it is, but this block there contains a definition, right? So if you
Can you
look
just
closely, you'll
squint a
see
little
that.
bit? It's a bit small.
Yeah. Well, anyway,
But I
we'll
know
share that
you
when
know
we
what a
have
definition is, I guess.
well, we're going to see that in the graph in a minute. But basically, that describes what an unavailable deposit is, right? And when and how does it become unavailable, and these sort of things. And you see that it has different, clauses in the definition. There's A, and there's a section B, C, and it happens to be across different pages, which can also be a problem, because if we look at the way we traditionally would take a document like this one and put it in a vector index, it would be that by doing what we call chunking, right? You take fragments of it in order to, you could of course vectorize the whole document, but then the precision of the search would not be very, very good. So what we don't normally do is chunk the document in small portions, create entries in the vector index, and then do searches on that. That's exactly what we're going to do in this experiment. But the main difference is that what you see there, to me, and I'm sure to many of you who are joining this session, it looks like a graph, right? Because you have a regulation that has parts. The parts have sections. The sections had. I already start to see a tree, and that's exactly the case. So that's we're going to see that in a minute. But if we model that in a graph, and I will not cover so much the construction because I want to focus on the RAG part. But you see how that, and actually the LLMs do help, and that's the part that Michael did in the Graph Summit. So you can also take that PDF and ask the LLM to do the structuring of the document, the extraction of the sections and the different parts in it, and generating probably JSON-based, XML-based, whatever, and that's something that you can then ingest into the graph. So the construction is also something that LLMs will help with. But let's start from the point where we have that already. So we have a node representing the legislation. It contains a number of parts, we saw in the previous screen. The parts contain sections. The sections ultimately contain definitions, and the definitions will contain clauses, right? So this is a standard graph. Now, the thing is, some of these nodes will contain fragments of natural language text, right? For example, the definition, like we saw before, will have a piece of text. Same with the clauses. And this is the kind of thing that I will want to first vectorize and then index in the vector index. So that's where the demonstration is going to begin. So how am I going to do that? Because I wanted to jump from the slides to my notebook. So before I go into the code, let me yeah, I should have thought of that actually, because I have a number of things running here. Good, because what I have is I have an instance, an Aurora instance that has the graph that I've just described already loaded.
Okay.
I have a notebook that I'm going to be sharing as usual in the GitHub repository, and yeah, my plan is to run it step by step, and maybe it's worth because I'm going to use this time LangChain, and LangChain, some of you may know, is kind of an orchestration package. It's a component in Python that really simplifies the construction of applications that interact with LLMs and that do things like RAG and stuff like that. So yeah, like I was saying, let me go back to the slide. So I have this graph already, and what I want to do is first take a bunch of the properties in these nodes and put them index them, vectorize them, and index them. So I'm going to do that with the help of it can be done in a number of ways, but I'm going to do it using LangChain. Sorry, jumping back, and I'll show this fragment. And feel free to not dive into all the detail, but basically what I'm doing here is doing a single call to this method called from existing graph, which basically is going to do the job of vectorizing certain properties and adding them to a vector index. And the way to pass the configuration, it's pretty intuitive. First, I pass, which is the embedding service, and in this case, I'm using OpenAI. I'm giving the credentials and the access point to my knowledge graph, and that's my Neo4j instance with my username and password. Then I'm giving them the name of the index. Every index in Neo4j has a name, and I'm calling this legislation. And what I'm going to do is tell this function, what you have to do is go take all nodes of a particular type or with a particular label and certain properties within those nodes. So that's the way I select the properties, the text properties in my graph to populate that that vector index, and then I store the vector itself in a new property that I'm going to call embedding. So all this is going to happen in a single call, so I don't need to care, and that's how this LangChain is great, because this rather complex multi-step process is going to become very straightforward. Now, some of you might be asking, hey, what's that embeddable label? I had not seen that before. And you're totally right. So there's a number of ways of, actually, I can show you what we have the graph here. So if I look at a clause, for example, there you go. We have some of them here, or even let's look rather at the definition. Okay, so if I take a definition, I see that it's labeled also as embeddable, but I can expand that, and if I can, let's make that a bit more readable. So this is the section that contains the definition. The definition, the section will be itself. Well, it will contain all the definitions. That was not a very good. Let me actually
maybe
take that from the notebook, because I have a nice query here that's going to return something a lot more readable. But what I wanted to show, let me go back to my legal one. There you go. So here I'm taking the one that we saw in the slides, the definition of an available deposit, and that takes the whole chain and makes it look quite nice. So we have the legislation at the root, we have the part. Actually, maybe to make it a bit more readable, I can make that bigger.
Yeah, that's good.
So we have the legislation at the root, then we have the part, the section, subsection, and then we have the definitions and the clauses in them. Now, what I've done is, okay, I have to select which are the nodes that contain textual information that I might want to embed. And my strategy has been, okay, I'm going to add an extra label to my definitions. This is a definition that I've also tagged as embeddable, and the clauses, I've also tagged them as embeddable. So now this embeddable is kind of an extra tag that I put on certain things to indicate my vector index. Okay, I will my vector index, my LangChain, go and take all these things that I've tagged as embeddable, and they can be of different types, and pick the properties that I'll tell you and use them to create the vectors. And that's exactly what we were doing in this section. So that's how I was passing this embeddable tag, which is an additional one that I've created as my way of marking the types of nodes that I want indexed. So that's what this is going to do. This is the magic of LangChain, that it does the whole thing. And once I have that, I have a handler here, this vector index, that I can use to run semantic search. So that's what this does. But let's jump now into the notebook, and let's run it for real, and we'll see what it looks like. So, okay, I've run the input. So I initialize my environment variables with my access point to the instance, to the Neo4j Aura instance, credentials, etc., my OpenAI key. And just as a test, because the whole thing here, and I'm going to show that in a mini application also in Streamlit, is okay. I could ask directly an LLM, kind of skip the RAG step, and say, okay, I can ask this question of what is an unavailable deposit directly to the LLM. So if I go back to this slide, I could say, okay, my application can ask directly the LLM, and I will get some result. It might be good, it might be bad. And in this case, it will give a better. I wouldn't call this a hallucination, because this, as you can see, this is returning what's an unavailable deposit, and it's probably based on general knowledge. But now that's probably not the answer that I want in the context of my legislation, my private information. So I use that as a kind of a baseline. That's where we start. But the next thing we're going to do is, okay, we have some information vectorized in the graph. Actually, I'm going to run it here. This is the fragment that I showed a minute ago. So all the credentials, I'm going to run this, and it should populate the graph, the vector index. And now we have a handler, that's this vector index, what I can run semantic searches, as in vector-based searches. And the syntax is pretty similar. I can just invoke on this object, vector index, that has been created out of this, a similarity search based on a question. And the question, as you've seen here, I've defined it. What is an unavailable deposit and how does it become unavailable? It's interesting because I've run this in a couple of other events, and it's amazing how you can run it in other languages and still semantic similarity works. We're going to see that later. But that's the reason why you find it here in French and even in Spanish I've run it. But anyway, so we have a question in natural language. So if I pass that question to this vector index similarity search, that is going to return the best match, and that's where the K1, I'm returning the closest neighbor to that question on my vector index. And that's returning effectively the node that's closer to the definition of an unavailable deposit, which is the definition node, the one that we saw before. Yep. Fair enough. That's kind of something to expect, right? But the problem is, as you saw before, is that this definition is incomplete because that's just the first part, because the definition contained 3 clauses that completed the actual definition of an unavailable deposit. So if I build a whole RAG chain, and that's something that, again, LangChain helps us with, and I believe that's the content in the next slide, although I might not go back to it again. But essentially, that's the construction of the Q&A, the retrieval augmented generation chain, where we pass the vector that we just created as a retriever. That's all. And of course, the LLM that we're going to be interacting with. That's what we're doing here. So if I create this chain, I can then run exactly the same question. And instead of getting this result as output, which is what's happened when I just query the vector index, what's happening there is it's building the whole chain. It's querying the vector index by using the vector index here, but then it's passing it to an LLM, which is this LLM, ChatGPT, and it's going to return the answer based on this context. So that's what's going to happen. So if I run that, that's going to give me a more elaborated answer based on this definition. And that's a lot better because that's already one step in the right direction. But still not happy with this because, as we saw before, we know that a definition may potentially contain clauses. So here's where I'm going to combine the vector search with the graph exploration. Maybe my match returns something like this because it's effectively the closest match. Mm-hmm. But I'm going to say for any match that you get, go and try to navigate the contains relationship. And if it contains any clauses, enrich the result and produce a more contextualized and more and richer kind of answer. So that's exactly what happens here. And I'm going to go back to my slides. And I don't know if that's going to make people a bit
No, it's okay.
But anyway, the idea is pretty simple. I mean, before we were calling from existing graph, and that would take the graph and populate the vector index at the same time. If the vector index already exists, I don't need to recreate it. And I can say, okay, give me a handler on this vector index and from an existing one, and I pass the name. The name is legislation. It already exists, and I'm going to use it. Same credentials, my user, my password, where my Neo4j instance is. And the additional element, and where the magic is going to happen, is this additional configuration component. I'm saying there's a retrieval query. And this query is some cipher, some random cipher that I'm going to configure. I'm going to show you what it looks like. And that's what I'm going to say for any match that the vector search returns, go and run this cipher, because that's going to enrich the result. And that's exactly what we are doing in this next step. So here we go. So that's the code. And you see that's the fragment that I just showed. And this is the query, because the graph is pretty standard.
Magic.
Say again?
That's the cipher magic.
Exactly, that's the cipher magic. And in this case, it's pretty simple because, the graph, I've tried to build it in a pretty consistent way where there's a contains relationship. It was a tree, and the legislation contains parts, the parts contain sections, the sections contain definitions, the definitions contain clauses. So if you just navigate the contains relationship, you could even make it like a variable length one and get as many child elements as you could. And we'll discuss how making that generic can be powerful. But we have now this contextualized vector store, which is, again, it's a pointer, it's a handler on my vector index, but now it's enriched with this query. So when I run a question, pretty much like I did before, the same question and the same limit, I should get something different. And if we've had, there you go. So we have the definition that we had before, but now we get the three clauses following it. So if I pass that to my RAG chain, and I'm creating here a new RAG chain now using this enriched contextualized vector index, I can rerun my query and print the output. And hopefully I'm pretty convinced, unless things go wrong, and but this is going to look a lot better. Because now what we're doing is, okay, we're asking a question, and we're going to the graph. There we go. And that's a much richer, a much more complete definition. An unavailable deposit is a deposit that's supposed to be paid, blah, blah, blah. And it can become unavailable in three possible ways. And basically, it's literally listing the three clauses that we had in the graph, right? So that's how this combination of vector search that finds the closest to whatever my question in natural language is after can get enriched by exploring the knowledge graph. And now, just to show the whole thing in action,
cool.
I mean, that's because this is fine for techies that are watching us, which is probably most of them. But the kind of thing that you're after is something like that. Oh, and it's already run. Damn it! I wanted to. But anyway, let me start from scratch. So we have I've created this basic Streamlit app, which basically has exactly the same code behind. The only thing is it creates an interface on top, and what we do is I enter my question in natural language, and I have the three interactions that we show. That's what happens if I ask directly without any RAG. If I go straight to the LLM, that will give me potentially a valid no hallucination, but completely no context. I mean, at least not the context that I'm interested in, which is the fact that I'm talking about this particular, and think of this legislation as any enterprise private data that has not been used for the training of the large language model, and therefore, no context is available on that side. So that's the kind of answer that I would get, which is plausible, but not what I'm after. The second one is a bit better, but it's incomplete, right? Second step, we just do the vector search and get the best match. But then the third one, it's actually the richest one, and it's the one that I'm really after, because it returns, following the whole process, all the context around the vector index results. Okay, I'll take a quick pause here, short pause here. Any questions? Does that make sense? So
I that's very cool. I think especially now that you show the side by side, I think it makes it very clear that the one after the other, or one or the other result is much richer, much more information, much more contextualized, as you said. So I think that's important, because we say this, we use the knowledge graph to ground stuff, to contextualize your results, but what does it actually mean? It's a very good demo.
Exactly, and it's also a kind of a demonstration of how vector search only, it's not as rich as vector plus graph plus knowledge graph, because sometimes and some people think that maybe a vector database is enough, and it might be for some cases, but if we have a proper rich context capture in the knowledge graph, that really enables for much richer and more precise results. So that's the idea.
Yeah. I mean, with the vector, you kind of like get to the right. Let's say, if you imagine it's like being an area, like a space of the graph, you get to your point where you want to go in a very quick way, but then it stops there. It doesn't give you more information about it. It's like as if you were getting directions of saying, hey, I need to go to City Hall, and somebody says, yeah, it's at, I don't know, City Hall 1 square, and then you get there, but then they don't tell you anything what's around it, and they say, okay, yeah, here's I don't know, some other locations around it that needs to be informed about the whole that makes the square, makes the information about it.
Absolutely, yeah, and it goes beyond that. I mean, it's probably not something that we'll have time to show here, but if you think of it, you can do a lot more there. I mean, you can apply access control. I mean, the moment you have the graph, you can be more fine-grained. If here, I'm not modeling any kind of user configuration, but if my graph is user aware, I can even return personalized results based on who you are, because I have control over the results plus the navigation that comes after. So yeah, absolutely. I think the richness of the context return is significantly improved. So
Yeah,
that was
yeah.
the
There's an
first.
interesting question from Gopesh about what's needed for this to work in such a way. And he says it seems like a contextualized RAG needs a highly enriched knowledge graph. Would you agree with that, or how
Well,
would
I
you
mean,
say?
yeah, I mean, it requires a knowledge graph. I mean, the thing is this is, and that's probably something that we'll cover again in future episodes. But you definitely need a graph. You need some kind of, in this case, some awareness of the structure. But I wouldn't say
Yeah,
it's a highly. I mean, it will be enriched over time. But this, I would say, is a pretty, straightforward type of structure of a document, right? If you think of it in other context, it can be a documentation. I think that's similar to what Adam has built in our Graph Academy, right? So you can have,
mm,
a different type of structure for courses or even for web pages. So I think the construction of these should not be. I don't know if his question is more in the direction if it requires a massive effort. I mean, it requires definitely some awareness of the context and of the structure, but I don't think it's a huge and significant effort up front. I mean, it's probably bigger if we get into something that we covered in previous session, like entity extraction, where you have to build richer structures. But this one is I would say pretty approachable, and something like I say that will grow organically over time and will keep enriching, because it's true that in this case I've created sort of a custom query that follows you see that it's the contains relationship that exists all over the graph, right?
yeah,
You can go meta there, and that's the plan for next episode, and actually be more dynamic about that. So maybe I'm not going to pass the cipher there. I'm going to configure that on the fly with applying ontologies, applying some annotation of my graph. So we'll go into that, but to the question, yes, you need a graph. I don't think this is a massive effort. This is relatively straightforward to build graph.
yeah. What you need though, and I think Kopesh then adds this in a chat message later, is having domain knowledge, obviously. So if you
Well,
set this up, and if you like when you went through and you put the nodes with embeddable as a second tag on it, as a second label, then
yeah,
you
that
understood, okay, what's important, what do I flag as the expert, the domain owner, or the domain
yeah,
expert.
that's a fair point.
Uh,
Although again, this is the first example that focuses more less on the domain knowledge and more on the structure of the input
I
of the
see.
of
Okay.
the. So here it's more about, hey, there's sections, there's parts, there's definitions, and yes, in general, I understand that definitions are important and the kind of things that I'm going to be looking
For sure.
for. But yes, I mean, of course, the richer and the because the value proposition here is that this knowledge graph is not just a means to enrich RAG. I mean, the building knowledge in the knowledge graph is a great investment of effort. I mean, it's going to deliver value in many different fronts, right? So I think it's valuable in many ways. But in this particular case, it's true that I focus more on the structure of the document than in the domain knowledge. But that's exactly what we're going to cover in the second example, and what we saw in previous episode, for example. So yes, building
Yeah.
knowledge, building domain knowledge in the graph is definitely an effort. That's worth it, and that you should definitely invest time on.
Absolutely. Yeah. Sit down with your experts, sit down with the team. It's the usual. It's very approachable for everybody, even if you have no ideas of what a graph database or even what a LLM or RAG means. If you show this to somebody, or from your legal department, and say, hey, what's the important part here, then they will be able to tell you what what should be
Yeah.
flagged and what shouldn't. Maybe before we go to the next example, because it's an interesting question from Peter here. You use an embeddable label, but could you have just used the text node type of node instead?
The text. node type. So, I mean, you can do it in many ways. I mean, what you need to populate the vector index is define a pair of label and property or collection of properties. So I've seen it done in different ways. Some people, what they do is they have the node and they create an external separate node that contains the actual unstructured text. And that might be good for a number of reasons. I mean, depending on how the graph is being used, maybe it's true that having a large chunk of text in a separate node to enable all the types of accesses to the graph. So that could be another option, like having these nodes definitions linked to a text or to a vector, and then you say, okay, that node that you can label as text or as vector is the embeddable one. So you can do that in many different ways. So if that's what Peter means, absolutely. So you can do it in. I mean, that's my way of doing it, because I kind of like the sort of compact graph that this creates. So I just add an additional tag to these nodes, and it's all kind of bundled in the same node. I could have extracted it to a separate one, and that would be absolutely fine. Yeah.
Cool. Thank you.
Good. So that's experiment one. Now the second one is more. It means less about the structure of the document, and it's more. Let me go back to the slides. Let's start that. 1 second. And yeah, so this is covered. So here's the second one. So we have a, oops, wrong. That's where that popped up from. Anyway, so yeah, this is I'm going to try and create an art gallery assistant, but this is not going to be a kind of a conversational one. This is the one that's going to generate some personalized emails in this case. But the starting point is I've looked at the Tate Modern here in London. So they have their catalog online. And the catalog looks like this page that you see on the left. So there's an artwork, and there's the information about the author. There's lots of textual information, and some subjects that are touched by this artwork. So I've loaded that in a graph, in a very simple graph, and basically the attributes of the artwork are built into a node that represents the artwork, which is what you see on the right hand side. Things like the dimensions, the materials, the medium, as they call it, like the materials that are being used, the date, some description, the kind of display caption. I mean, what you see in the museum if you go and read the label next to it. Then, in addition to that, there's a node representing the author, and then another collection of nodes, the blue ones, that are the subjects that these touches on. So this particular one is about figures, dynamism, geometry, abstraction. So these type of concepts that are that describe the artwork. So that's the graph that we have. So here there's no notion of structure of the document. What we have is standard type of graph. And what I want to do here is something, oops, before I go into the code, because I mean, the objective here is slightly different. So I'm going to, again, same idea. I'm going to pass to my LLM information that I control. And basically, I'm going to give the facts for the LLM to generate a personalized, let's call it an email that's, let's say, Alex is going to visit the Tate Modern, and you enter a topic of interest, and then the agent is going to look up the catalog and give a recommendation of these are some artworks that you should go visit, and that is why. Yeah. So instead of, again, delegating that to the LLM, I'm going to take ownership of the facts. Again, this is, of course, the Tate Modern is public data, but think of these as your own enterprise private data. So the LLM is not aware of this information. So what you have to do is find the potentially relevant data. That's the idea of RAG, and pass it on to the LLM in context for it to generate the response. And yes, let's go into the code. It's slightly more cumbersome, still using LangChain. But the idea is similar in concept. So what we're doing here is okay, we're we're defining here what we call sort of let's call it an application. So in principle, what we're doing is here I wonder if I should show the demo first. It's going to make it more understandable. But anyway, so effectively what I'm passing is, well, the customer name. And this is just, of course, not just because I want my email personalized, but it's a way of indicating that I could pass some identification of the customer, of the user, so that you can even further, like I said before, filter, personalize in the results. So that's one thing that this example doesn't do, but could be done. And then a search prompt, which is some form of search string, a question, like we saw before. Before I was asking what was the definition of an invalid deposit. Here I'm going to ask how does Andy Warhol address the topic of happiness or whatever, and then you'll take that to generate this sort of guide. So these are the two inputs, and these are the two parameters that I'm going to be passing as input, and this is going to be used on this function that I call recommendations app, that you will not be surprised to see that it's exactly the same thing we saw before. So this is going to be a vector index handler, like the one we saw before, and this is the similarity search that we run in the previous example. So no difference. I'm going to pass the input, and in this case, I'm returning the top 3 results, and just joining them into a chunk of text to return. So this is just wrapping the same processing that we were doing before, but in a function, because then I'm passing that function here to this kind of chain. I mean, I won't go too much into the details of how this syntax, which is a bit weird, but basically think of it. This is the input. Then I'm going to show the prompt, how we use this input in a prompt. We pass that to the LLM, and then we stream out the output. So it's kind of a declarative sort of syntax to indicate how the chain happens. And the other part that I want to show is what this prompt looks like, because the prompt is critical here. Because what I'm saying is, okay, I'm going to pass some context, which is the output of the vector search plus the graph navigation. But look at what I'm asking the LLM. I'm saying, hey, you're a personal assistant for an art gallery, and you have to write an email to the customer name that I'll pass you, who's a member of the gallery, and he or she is planning their next visit. So the email should summarize, the artworks that they have searched with the search string, and I suggest, okay, why not introduce kind of a joke, see how it does, and but I insist, please only use the artworks or the context that I'll be passing in context. So again, don't use your knowledge of the world, just use the knowledge that I'll be passing, and that will be the result of my retrieval from the knowledge graph. Well, and so on and so forth. I'll pass with them the URL. I want the URL to be also visible in the output, and that's pretty much it. So that's the instruction, the prompt sort of definition, and I will be passing a list of relevant artworks from my graph based on the search that I will get from the user. And again, that's just standard LangChain syntax. You'll see that in the notebook. And once I have this prompt application, I'll invoke it, and you will see the results. So before I go into the next section, let's jump to yet another. Oh, I have to reconnect now. But okay, bear with me. I'll do the input. But again, you will see some pretty familiar elements. So still same thing. Now I'm connecting, and don't worry about you seeing the user and the password. This is a sandbox that I will after this session. And even if you use it, it's not a problem. So I'm going to be perfect. So that's already been installed. I can get rid of that. So I define my environment where my instance lives. This is another one that I have. Of course, it's gone sleeping now, but it's here. So the graph that I showed a minute ago is already in my sandbox and should be visible here anytime. There we go. So we have the artists, the artworks, and the subjects, and so on and so forth. So you can see how. There you go. So this is an artwork, the topics, and so on. So that's the one I showed. So back to my notebook. So here I'm doing exactly the same as in the previous example. So I'm creating in this case I'm not populating the index. It's already been done. And what I'm saying is just like I did before. In this case, take the artworks and use the title, the display caption, and the artist. These are the fields. Sorry, the properties that I want the index to capture in the vector and to add to the index. So that's I won't repeat it. It's exactly the same thing we did before. I'm storing the embedding in the embedding property. It's already been installed, and the index is going to be called artwork. So I think it's done. There you go. And now I have a handler, and I'm ready to do exactly the same thing as before. So I can ask a question, and I can do a semantic search based on, for example, I'm interested in works by Constable featuring buildings. Natural language question, search string. If I run that, and again do a simple vector index search and get 3 results, this is going to return 3 nodes in the graph. Here we go, and it's going to return the title, the display caption, and the artist, which are the 3 that I embedded. Right. So these are the 3 closest matches based on these fields to my question. Works by Constable featuring buildings. So that's my context. But in this case, again, like I did before, I don't want to pass all this textual representation to the LLM. I want to pick portions of information that I want to be used for the recommendation, and that's what I do with my retrieval query, like I did before. In this case, what I'm doing is I take the artwork and navigate to the subjects. You remember how every artwork contains a number of subjects? So here I'm aggregating them.
The blue nodes, if you remember.
Same logic as before. I connect to the index, but I pass this retrieval query. And the retrieval query means every time you find a match, enrich it with whatever this query returns. And this is exactly what this handler does for me. And I put it in a function, just like I showed before. I'm just wrapping it in a function because that's what I'm going to pass in the second step. Just to test it, I could call it with my search string of the Constable paintings. So if I run it, this is the kind of output that it produces. It gives me the title, the author, the medium, and the features. So I ignore all the blah, 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 all the text, and I want to pass that to the LLM so that it produces the recommendation or the personalized email exclusively based on that. And then the URL in case you want to click on this. So this is my top 3. I'm limiting it to 3. And now pretty much the same way, but now using the prompt instead of the direct RAG that I showed at the beginning. I create my prompt definition and the application like I saw before, like you saw before, because I showed it. I'm just running the code that I showed on the slides. And from here, all I have to do is call it. And of course, I'm going to call it with you, Alex. I'm going to say I'm customer Alex. And I'm interested. The 2 parameters that I need to pass is my search string, which is the one that we saw before, the Constable paintings. And that's my name, Alex. So if I run this, it should now chain the whole thing. So it's going to take the search string.
Should get an email now. Yeah.
Exactly. Do the vector search, return probably these elements, then pass them to the LLM, apply the prompt and pass the prompt and the context. And this should generate something that looks like an email that that my agent, or the agent, will be sending you on your mobile app when you go to the Tate Modern, saying, Alex, that's what you have to do. And I'm really curious to see how they do with the show.
Yeah, that's probably why it's taking so long. It has to come with a good one.
Something like that. So you see, the subject, your next visit to the gallery, Constable masterpieces away. There you go. So dear Alex, I hope this, blah, 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 all this thing. And incredible artworks by John Constable. Blah, blah, blah. So all looking great, right? So there's, and of course, as expected, this is one thing that you should go see. And that's why. And here, in this case, that's surprising because one of the things when you invoke on an LLM is that the results can look different at each time. And here it's somehow been very, very kind of not very verbose, right? It's literally taking the elements and putting them in a kind of you see as a list, like medium features. And it's true that this one is kind of build the phrase out of it rather than just put the list. But yes, it's decided to do it in this way. And then it says, click here to view the artwork, blah, blah, blah. And now here comes the art pun for you. There you go. Even though Constable works are truly building a legacy in the art world. Well, pretty bad. And actually, I don't like the fact that it says, "Here's the pun for you." I would have liked it to kind of subtly,
Yeah, so
blend
weave
it
it in
into
a
the
little
text.
bit
But
more
anyway,
into the
it's not
text.
not
Yeah.
perfect. But you
Yeah.
see the idea, right? So in this case, it's built. And again, I've done something similar to what we did before, and I'm going to say the same, right? So I'm going to pass. I'm Alex, and this time I'm interested in. I have an idea here. Why not? Because that's what Alex asks himself when he goes visits the Tate Modern. I'm interested in artworks that focus on geometric forms.
Actually, I like those.
Well, I was doing the research. I came across this one, and I found it beautiful. I
Yeah,
just loved it. I mean, I hadn't heard before about this artist, John Wells, but I can't wait. Good thing
it's
is this is
really good.
just around the corner from the office,
Yeah.
so I'm gonna go have a look. But I really loved it. That's a great example. So, and that gives the the application. There we go. So we have and that's what it would look like, the final product. So it will produce an kind of something that looks like an email. I hope this email finds you well, blah blah blah. And you see all
This is
these
different.
things
Yeah.
it's different. You see, so now it's gone with a more kind of standard kind of paragraph style rather than a sort of a bullet point. But the good thing is that these things are clickable. So now you can see spiral movement, and you can go and see actually the page. And let's see with the pun here. I have preference to that. It's just skipped it, right? He didn't do a
It
joke this
didn't
time.
do it. Yeah.
Oh yeah, and remember when it
Oh,
comes
here
to
it is.
art, it's all about finding the right angle. There you go.
Okay, that's better.
Anyway, well, that's but that I like because sometimes we tend to focus too much on the Q&A type of, and they are interesting, of course, and that's great for I mean, for example, we mentioned before the Graph Academy. When in a kind of a training environment, being able to
Yep.
ask questions is great, but sometimes it's really powerful to use LLMs to generate highly personalized content, and this is a great example of that, where I leverage the LLM for the generation of these kind of natural language content, but I give the LLM exactly the information that I wanted to use, and I kind of take ownership and control over the actual facts, right? And again, back to the idea of the explainability, I can I give the sort of the provenance in a way by giving the URL and the link, the clickable link. But yeah, like I said before, that can go even further, right? So here I'm passing the fact that I'm Alex. I would pass, if this happens in a session, I would have your user credentials, and I could use that to even further personalize, right? I know who you are, I know what you're interested in. Without you telling me that you like geometric forms, maybe you just need to say, hey, I feel happy today. Tell me, what should I go see? And because it knows and it accumulates information about you, it
Yep.
can provide something relevant based on the knowledge that's stored about you in the knowledge graph. So
Yeah,
yeah,
or like
another yeah. Go
imagine
ahead.
you have a user. I mean, the examples that come to mind is like Board Game Geek or Goodreads or something like that, where you have your reading list or your board games you play and the ratings and all of that, and you can say, okay, I have a user, I want to send them a personalized email. I know what they like, I know what they played recently, I know what genres they go for, and then I can combine the two.
Absolutely. So that's I hope that's that's given kind of an overview of well, at least two examples of how the graph can play the role of this kind of brain that
Yeah.
knows all the facts and gives us control over them, and how we can decide what's how we enrich, how we expand, how we contextualize these facts, and then we pass it to the LLM, because the LLM is great at at reasoning, at generalizing, at doing analogies, at generating text, as we've seen, as having conversations. But we keep control of the facts, which is extremely important. So
Yeah.
that was the idea. And to your point, Alex, I wanted to conclude, and I'm conscious of time, with a final slide, with where to go next. Because there you go. So that's some content that Dan Bukowski, from one of our colleagues in the US, has been creating over the last few months, and I think it was presented. I don't know if I mentioned it last time, but it's super interesting because it goes in exactly in that direction that you said. what he talks about is how the graph can not only contain the actual facts, the knowledge about the domain, but it can also store the conversations. I mean, this interaction that we've had with the graph when we ask about what's an unavailable deposit in the legal example, well, it can be stored and it can persist what your question was, what the answer was, which chunks of which bits of the graph were used as context to generate that content, right? And like this, it's building again a history of all the interactions and all the knowledge that you've been exchanging with the LLM, and that again can feed future responses and build a more personalized experience. So that's definitely something that people should go look at. There's a bunch of blog posts, and there's even a YouTube session pre-notes where him and Alex went over the what they had built with when was that? I think that was that was before the Road to Notes.
The Road to Notes is like a workshop training, a little bit longer content, but more hands-on, more tutorial style. If you want to do it yourself, you want to learn how to do it. If you want to get some step-by-step guiding, then this definitely worth looking at.
Yeah. So that's that. And for us, what's next? Like I mentioned before, because here one thing that I we like, how we like to go meta here, right, Alex? So we, like I mentioned before, I don't want to have to be explicit about my cipher. So how to, depending on the question, how to expand it. I want to be able to control that by annotating my graph. So that's what we're going to be covering next, because I think it's an interesting topic. It aligns with our kind of general topics of semantics and ontologies, because the way I see it is I'm aware of my knowledge graph, and I can say, hey, this is a property, this is a node that can and should be expanded, should be enriched. And the way to do it is by using these relationships, providing these type of annotations, so that the retrieval part of the RAG will be able to leverage that to do something in a more dynamic way. Because now, the way I built it, if I want to change my logic, I have to go and change the cipher and then get a different behavior. But so that's the plan for next. Probably. I mean, unless we think of something else.
Come up with something else. But yeah, that sounds great. Sounds good. Very interesting.
Good. So that's what I had for today. I mean, I'm really happy. I hope it was, all the code will be there. I might have gone a bit too fast. If you are not familiar with LangChain, it might be a bit too much code on the screen, but hopefully it was at least understandable at a high level. And then when the different components, the notebooks and all that are in GitHub, you of course free to go play with it yourself, and it will all become a bit more clear, hopefully.
Yeah, let us know if that was the case, or if not, that was the pace was great, and then also let us know about that. Miguel asks in chat, when will be notebook and the graph available in the repository? I think probably it is already.
Well, not this time. Sorry,
this time.
But it will happen, in the coming hours. I mean, tonight for sure.
Later today, latest tomorrow. Check it out. The GitHub repository and the links are in the video description, either on YouTube or on our landing page. So check it out there, and you'll find the information on the code and all the snippets from there. There was one more comment from Daniel I wanted to read out. Daniel says, so many benefits from the knowledge graph, both on the human and on the machine sides. Seems downright foolish not to apply them broadly, especially in the case of a Gen AI application.
I could not agree more.
Yeah,
I mean, it becomes more and more clear that there are a perfect combination, right? Like the brain, as in I know I've said it 100 times, but I'll say it 100 more. Like the brain, the facts, the curated, the explainable, the trustable knowledge, and then the reasoning, the creative capabilities of LLM, and the combination of these two are really, really powerful. I mean, this is, of course, I understand these are sort of like everything we build in this series, the toy examples, but I guess the concept is pretty easy to get and pretty easy to extrapolate to really large scale applications, and we're talking about really relatively easy to build solutions. So yeah, totally agree with Daniel. It's a super strong combination.
Yeah, and even like you said, even though there are toy examples, I think we'd like to encourage you to try these yourselves. Obviously, in a toy environment, but you can take it on to the next level and take a snippet of your data. I mean, if you're working with something where you have a use case that goes into this direction, you don't have to go all in right away. You can say, okay, I want to try this out. I want to see if the improvement is there right there, and take a sample set of your data and see for yourself how it benefits and how it improves the results. And you know, looking at this today, and then on the other all the other sessions we did before, and on other streams and video and written content that is out there. And like what Daniel said, I think you will immediately see there's a benefit. It was very evident today with the written PDF use case. But if you imagine you have your own data, then give it a go for sure. And then there is one more question from Orolesco. Do we support Haystack as well?
Oh, good question. I'm not
Do we
familiar with
know? I
Haystack.
don't
Let me
know.
see. Haystack. Oh, I'll need to find out. I'm not familiar with Haystack, to be honest. Well,
Yeah,
but yeah, I'll have to get back to you on that. So, framework to build production ready applications. I've I can't give you an answer right now.
yeah,
Let's take that offline and we'll get back to him. So I haven't. It looks like it's a framework to build applications, but I don't know. I mean, I wouldn't be surprised if it's based on Python, .NET, or any of the languages that we support with our
it
drivers.
should
That
be. Yeah,
should be pretty
yeah,
straightforward. But yeah, we'll do a bit of research and get back to you on that.
yeah. Cool. All right. I think that brings us to the end of today's session. Thank you very much, everybody, for watching. Thank you very much, Jesus, for yet another great hands-on demo together with slides and great background information. So this was super good, and I hope we can continue on this exciting journey forward. Exploring more RAG, exploring more LLM, chatbot,
Yeah,
knowledge
possibly.
graph combination. The world there is I think very very much interested in this, and you know, like
Absolutely.
everybody else is
But
is
the next
great.
one will be in 24 already. So that
The
was
next one will be in 2024 exactly. So new year. uh, do, don't be scared, but it's exactly true. So we are looking at January of next year
that's right.
for the next episode. And yeah, before we wrap, I'd like to say thank you all for watching. Thank you for being part of Going Meta through 23 episodes now with me, Jesus, and thank you all for watching. Some of you have been watching from episode 1, so it's been really great, good fun for you to accompany us through this journey through the various topics around knowledge graphs. And I think we got a couple more or many more, hopefully, in our back of mind of what other topics we can cover in this series. So it's not going to go away. So we're very happy to have you as viewers, as watchers, as commenters afterwards, and we'd like to keep going. So it's great. It's good fun.
Excellent. Well,
Yeah.
see you all. Have a great end of the year, and see you in the next one.
See you in the next one. Exactly. If you are interested in RAG and all that stuff, we are doing a Neo4j live, or I am doing that together with Tomasz and Leanne on powering advanced Streamlit chatbots with GenAI. So very similar topic to what we have today. So if you want to know more, if this topic is interesting, tomorrow at same time, same place, basically 5 p.m. Central European time, we're going to do that. So tune in tomorrow, and otherwise we'll see you in January. Take care, everybody.